Hi dear students, today we have come with a new video of class 6. In the previous class, we have got an outline of force, the introduction of force, and there we have learned that how we can able to apply a force on our body. Okay, and due to application of force, what effects can be occurred, as well as we have got the characteristics of force with definition and units of it. Okay, today our target is to learn the kinds of force. How many types of forces are there? Okay, so that one we have to discuss here. Kinds of force. See, we have applied force on a body in various ways, and depending on the application we can divide force into two types. Okay, we can take two types of force. So if we write here, one, it is known as contact force. Another one, it is known as non-contact force. So how we have got, or how we have divided, we have got these two types based on the way of application. So first we define the contact force, then you understand what I'm just trying to tell you here. So if I define contact force, it is told that in which force, it acts on a body by making actual physical contact, is known as contact force. What does it mean? It told that in this case, this is a type of force where when you have to apply the force on a body, in that time you have to make physical contact. Assume if I want to force on the board, I have to touch the board. Physical contact means touching an object. If I want to push a body, if I want to pull a body, if I want to stretch a body, or if I want to squeeze a body, in every case I need to touch the body, and in which case we have to apply the force by touching it or by making a physical contact. That is known as contact force. Okay, if I'm talking about the example of the contact force, that examples we have to discuss. Definitely pushing a block, pulling chair, right? Stretching, spring. In every case, we need to apply force on a body by touching the object or touching the body. That is known as contact force. Okay, now we'll go for the non-contact force. Definitely it will be exactly opposite to it. What is that? Forces applied on a body without making any physical contact, is known as non-contact force. That means you are applying force, or the force is applied on a body, but there is no connection, there is no touching to a body, there is no physical contact to a body. Now you might be asking, sir, Is it possible? I am applying a force, or the force is applied by somehow another agent to a body, but there is no connection between the body and the body is applying force. How it is possible? I have given you an example. If I have just left the pen from here, what will happen? You will say, sir, is it a question? Definitely the pen will falling down. Why? You will say that definitely the force is acting on the pen, that is gravitational force of earth. You don't know Newton? Sir, Isaac Newton has already told that everything which is on the surface of the earth, that is attracted towards the earth by a force that is known as gravitational force. Now I'm asking to you, sir, is there any contact between the pen and the surface of the earth? Is someone is pulling the pen? Is some invisible hand has come and take it to the ground? No. There is no connection, nothing else, but till the pen is coming downward due to a force. So we can say that number one example, that is gravitational force. Definitely, it is a non-contact force. Not only that, we all are very much familiar with the magnets. We know the magnets can attract the magnetic substance. Okay, if you are having a magnet, assume it's a bar magnet. I'll show you here. Don't be panic. Whenever we have to explain each and every example, I'll just show the magnet also. So if it is a magnet at a distance, assume there is a pin which is made by iron. Okay, so it can able to attract the pin. So have you seen the magnet should have some hands are coming out from here and it goes there and taking the pin towards it? No, because it is also a non-contact force. The force is attracted by the magnet to the pin, but there is no connection, no contact between them. So we can say that magnetic force, that is also a non-contact force. In this case, the forces are applied on a body, but there is no connection between the object and the body. And now we will discuss each and every examples of contact force and non-contact force. Let's see. First thing we will see the examples of contact force. Okay, so first example, it is known as muscles force. So whenever we are talking about muscle, all are thinking about, sir, are doing about this muscle, biceps, triceps, not like that. All that work we have done by ourselves by applying our own force, that is known as muscle force. Assume I am taking a book on my hand. Okay, I am pulling the book, I am lifting the book, I am pushing this board. Everything's are known as muscle force. Okay, you are just taking an object, you are just lifting one bucket of water. Everything is muscle force. So muscle force, it is one kind of force, just like if I assume that it is a block and somehow it is pushing by someone. Okay, so someone is pushing it, pushing the block, that is also a muscle force. Okay, so any pushing or pulling done by some person by his own effort, that forces are known as muscle force. So muscle force definitely we can apply to our body by contact, by making a physical contact to our body. If we are not able to touch the body, then I can't able to apply my muscle force over there. Okay, assume I want to beat a boy, though I don't want to beat anyone. So if I want to beat anyone, so I have to touch him. I cannot able to beat by staying at a long distance. Then somebody can say that, so you may throw something. No. If I throw something also in that object, I have to touch and then apply the muscle force there. So muscle force is such kind of force where you have to apply or you have to touch the body. Okay, so that is one kind of force which is a contact force. Coming to the next one, and which is very, very common, number 2, that is known as frictional force. What is frictional force? Assume if I just want to make an object move over a surface by applying a force. Assume the object is kept over a surface. I am applying a force here to move the object in this direction. But to move the object I need to apply much amount of force, because a force is just trying to oppose its motion. Okay, that is known as frictional force. Now it might be little difficult for understanding. Now I have shown you an example. Assume I am having a board, I am having an object. If I want to apply force, you see, after moving some distance, it is stopping. Why? What is the reason the body stops? You say that, sir, you have applied force on the body, but as it moves over this surface, the surface is little rough. And due to that reason, there is a force which is acting in opposite direction of the motion of the body to stop it. And that's why after moving some distance, it is stopped. Okay, it is not moving continuously. Clear? So that force which just try to prevent the motion of the body over a surface, that is known as frictional force. And definitely, to apply the frictional force on a body, the body should make a contact over another surface. If the body is not in a contact, if the body is at a height, then is there any frictional force will applied by the surface to the body? No, definitely not. So to apply the frictional force, the body should make a contact with the surface, and then only a force is acting opposite to the motion. So here if it is told as force you have applied and the force acting in opposite direction, that is known as frictional force, which is acting opposite to the motion of the body. That is one kind of contact force. Clear? So what is frictional force? We will learn later more, because in your book the more emphasis is given on frictional force. There we have to learn more on that. So now we have to understand that frictional force is a contact force. Coming to the next one, that is also very, very important one, that is known as tensional force, or sometimes it is known as tension. Okay, tension is not like that you are thinking about the tension is coming on your head. No. Tension is a kind of physical force. Where it is applied? Simple thing. If you hang an object from a height by a rope or a string or a thread. Okay. So in this case, if you hang it, then you feel that one force is acting here opposite direction of the body where it is hanged. Okay. That force, it is known as tension. Okay, maybe it is to think about this tensional force, it is little bit of difficult, because you can say that we cannot able to feel it. See, whenever we are talking about the object, the weight of the object, so what is weight? We will discuss more. The weight means the force applied by the earth that is acting downward. Okay, that is known as the weight which is acting downward to an object. Okay, any object, if I have left it from here, we all know that it is fallen down due to its weight, due to the force of gravity. So what is the force of gravity? That is weight. In the previous class, you have asked, many of you have asked some question that, so force and weight. See, weight is a force which is applied by earth to a body. Force and weight are same. And when that force is applied by earth to a body, that is known as weight of the body. Okay, so that one I just want to say. So weight is acting downward. So as a force is acting on a body, you will learn later, then in that case there is a reaction which is acting on the thread or on the rope where it is hanged. That is known as tension. Okay, so if you pull it, due to this tension it is coming upward. Simple thing. If I have shown you here, if you hang an object, okay, so the weight of the body, it is acting downward, okay, and the tension is acting over the thread. And definitely the tension, it is a contact force, because see, it is just with the contact with the thread. A thread is contact with the body, so that is also a contact force. Clear? So if nobody will, I'm sorry, the spelling is wrong here, I'm extremely sorry. So whenever anyone asks you about tension, you can say that tension is a force which is acting on a body when it is hung from a height with the rope, and it is acting towards the point where it is connected. So assume it is connected here, so tensional force is acting towards the point where the rope is given a knot or it is connected over there. That is a force. How it has come, that we'll learn later. Okay. Next, that's a very important thing. Tension is gone. So when tension is gone, then everything has gone. Okay. But here one more thing we have to learn, that is known as normal reaction, or it is known as reactional force. See, before telling about this thing, I am telling you one thing, that when we apply force on a body, that body will give a reaction to us. Assume if you beat one of your friends, then that friend will give a return to you. Definitely, it is not like that you beat him and he or she will go, he will give a return to you. Okay, so definitely whenever I beat, nobody gives a return, right? So if you give but physically what will happen, you know, whenever any object is applied force on a body, that body also giving a return force to the object. Okay, so assume it is a table. Here I have kept a book. Okay, on the table the book is kept. So we all know the book is applying a force in downward direction. Simple thing. If I have hold an object in my hand for a long time, it will apply a force downward. So after some time I can't able to hold it. I'll say just keep it here. I can't able to hold it for a long time. So simple thing, if you put an object over a surface, then that object will apply a force in downward direction, means on the table, and that table will give a reaction to the book. Okay, it is the rule, it is a law. That law is also given to us by the great scientist Sir Isaac Newton. So you will learn it, I think, in class 9. Okay, now you are only class 6. Wait for 3 years, then you will learn it properly. So now you have to learn, as the book is applying a force downward direction. Why it will apply a force downward direction? That is due to the weight of the book. Okay, and for that reason, this table will give a reaction that is denoted as R. Okay, and as it is acting, you see, perpendicularly. You have learned in maths now, perpendicular, okay, which is making 90 degree. So it is making 90 degree perpendicularly. So which is acting perpendicularly, that is known as normal. So that's why it is known as normal reaction. Okay, and in this case also, you see, you have to make contact with the body. Otherwise, the force you cannot able to apply. Okay, so these 4 forces we have discussed here. Apart from these 4 forces, and many other forces are here which act, but these are very much common. That's why I have discussed with you that these are the examples of contact force. Now we'll go for the examples of non-contact force. Let's see. So examples of non-contact force. Whenever we are talking about the example of non-contact force, first thing that has come here, that is gravitational force. So when it is come to our mind, we are just thinking about Sir Isaac Newton and the force is applied by Earth towards us. That is known as gravitational force. Simple thing will tell, if I thrown a ball at a height, the ball will fall down to the ground. Okay, in this path. That means Earth attracts everything over its surface. But whenever we are talking about gravitational force, in that case, we are not talking about only Earth. It is told any two objects are attracting each other by a force. That is known as gravitational force. Any two object means any two objects. If I am talking about these two pens, they are also applying force on each other. Then you might be asking, sir, they are not sticking with each other, then why? Because the force is so small that we cannot able to feel it. If you are sitting in your room, all the things inside your room and you all are attracting each other. This attraction depends on mass and distance between the objects. So all the object which is having a mass, they should have a gravitational force. But as compared to the Earth, our mass or the mass of anything which is compared to the Earth is very small. That's why the gravitational force between them is also very small. That's why we cannot able to feel it. Clear? But there is a force which is acting. If I'm talking about two of my hands, they also have a mass. They also have some attraction. If you are going with your friends, you might be thinking, sir, if you are talking about masses, so one of my friend is there who is very heavy, so he is not attracting the other person. Compared to the Earth, his or her mass is also very less. Okay, so that's why you cannot able to feel gravitational force between yourselves or between the objects you have seen. But you can feel the force between the object and the Earth. Not only that, when we are talking about the heavenly objects or celestial objects like Sun, Earth, the another planets like Jupiter, Saturn, Uranus, they also have that gravitational force because they also have the mass. And due to that force only, they can able to rotate around the Sun in a definite path. Okay, if there is no gravitational force, then they will scatter everywhere. Due to that gravitational force only, they can rotate. So when we are talking about gravitational force, not only the force between Earth and the object over the surface of the Earth, the force between all the heavenly bodies, the force between Earth and Moon, Moon and Sun, Sun and Earth, Jupiter and Sun, Uranus and Sun, Jupiter and another it's whatever the satellites are there, everywhere the force is acting. But in that case, the force seems to be stronger because their masses are more. And in general objects, as the masses are less, that's why we cannot able to feel it. And here also we know that there is no contact is needed. Okay, that is known as gravitational force. And we all know the gravitational force is applied on an object by the Earth. That gravitational force is known as the weight of the body. So what is the weight of the body? The weight of the body is the force applied on the body due to the Earth. Force applied by the body applied to the body by earth, that is known as the weight. Okay, it is also known as force of gravity. Which is force of gravity? That is equals to weight. I have told here again that weight is also a force. Weight is also a force, but it is a force of gravity. So that's why the unit of weight, or rather SI unit of weight, that is known as Newton, just like the unit of force. CGS unit of weight, that is known as dyne. Clear? So just like what is the unit of force, that should be the unit of weight. But apart from these two units there are two gravitational units. There are two gravitational units. Okay, so these gravitational units are not belong to any other unit system. Okay, so these are some another units. In that case, the unit of weight is kgf and gf. Okay, so these two some units are there. These are known as gravitational units of force. Okay, and these are SI unit and CGS unit of weight. Clear? From where the units has come. Okay, so that one you have to learn in class 7. Till then, you have to remember this. Okay, short questions can be asked that what are the gravitational units of weight? That is kgf and gf. And what is the SI unit of weight? Which one is the SI unit of force? That should be the SI unit of weight, that is Newton. And what is the CGS unit of force? That should be the CGS unit of weight, that is dyne. Okay, I think you have got the idea of gravitational force. And previously only I have told that here no connections are needed. Coming to the next thing. So when we are coming to the next one, that one is also very interesting. I don't think you have learned it earlier. If you have not learned also, it is not needed. You will learn it later. What is that? It is known as electrostatic force. See, this is also a kind of force where no connections are needed. So how you get it? Simple thing. We all know that all the objects around us, it is made by molecules. Inside the molecules there are atoms, and I think you have already known, or you come to know later, inside the atom some smaller particles are there, which name is electron, proton, neutron. It is told that in electron and proton, they are having two opposite properties, that is known as charge. Okay, so initially an object is having uncharged because there is no charge inside. Now you might be asking, sir, inside there is proton and electron and you have told there is no charge. No. In a body, the number of protons will be equal to the number of electrons. Now you might be asking, sir, what is protons, what is electrons? We don't know. See, proton is a kind of particles which is having a charge that is known as positive. Plus V means positive. And number of electrons means there is a particle whose name is electron, whose charge is negative. Okay, and inside the body, equal number of positive and equal number of negative charges are there. Okay, and that's why the net charge of a body is 0. But anyhow, if a body gets some charge, okay, so assume I have taken a body which is positively charged. If a body I have taken, if the body is negatively charged, then there will be a force applied between them. So how a neutral body converts into positive and negative charge? that if you want to learn, then you can say it is occurred by rubbing. Whenever we have rubbed a object, in that case the object which is neutral, that is converted into either positive charge or negative charge. Okay, and this positive charge will attract the negative charge. There's attraction occurs, but here you see there is no connection between them. That is a force of attraction acting between the two opposite charges. Okay, if they are taking same charge, it is positive and it is also positive. In that case, there is no attraction. There is repulsion. Means this charge will repel this one and this charge will repel this. Okay, so that is a repulsion. That is same for two negative charges also. Okay, here also repulsion works. Here also repulsion works. And here works attraction. Okay, one example you can see that if you use a comb, okay, which you use to make your hair proper, so you comb your hair for a long time, then take this comb to some pieces of papers which are very much tiny. You feel that this piece of papers are attracted towards the comb, because as you rub the comb over your hair, in that time the comb will get some charge. Whether it is positive or negative, I don't know. But whenever you have taken to the piece of paper, the piece of papers have opposite charge and they were attracted. Simple experiment. That is an experiment of comb okay, and some piece of paper. You will see the piece of papers are attracted towards the comb. So these are kind of force that is known as electrostatic force, that is acting between two charged particles, okay, two charged bodies. If a body anyhow got some charge, and here also no connection is needed to make between them. Okay, and that is also known as non-contact force. Coming to the next thing, so electrostatic force is over. So last thing we will discuss from here, that is known as the magnetic force. I have already told earlier also that the magnets are attracting the magnetic substance at a distance. Okay, here also no connection is needed between them. So magnetic force, that is also an example of non-contact force. Okay, so for that reason I have just kept some magnet here. Okay, so this is a bar magnet. You see in one side it is written N, another side it is written S. Okay, you see it. So in one side it is known as North Pole, another side it is South Pole. Okay, it is told that the opposite pole are attracting each other. So here you see it is South, it is written S, it is North. You see they are attracting each other. Okay, so one South and another North will be attracting each other. But if I am taking two equal charges, then what will happen? Not charges, the equal poles. These two poles are North. If I taken it to here, so you see it is twisting, it is not attracting. You see, South can attract North, South and North is attracting, but the North and North, they are repelling each other. See, they are not touching each other, but just they repel. And here also you see attraction is occurred, but there is no touching between them. Then also the force is applied, and after force applied they are touching each other. But here you see, when it is coming towards the magnet, there is no connection, and when the repulsion is occurred, that is also you see, if I hand the object from you see, it is not attracting, just rotating. Clear? So these are the example of magnetic force where two same pole repel each other and opposite poles attract. And here also no connection is made. Okay, so as there is no connection, we can say that it is also a non-contact force. And whenever we have read these three kinds of force, you see there are some characteristics we have observed. So what are the characteristics we have observed here? So first characteristics we have observed that apart from gravitational force, the electrostatic and magnetic force can be repulsive. So repulsive means there is a repulsion. Gravitational force is only one kind of force, there is only attraction occurs. But for electrostatic force and magnetic force, we have seen that there may be attraction if there is opposite charges or opposite poles, and in another case there will be repulsion if there is same pole or same charges, there is repulsion. Okay, so that's why these two forces are known as the repulsive forces, and gravitational force is only attractive. So we can mention it is only attractive, and electrostatic and magnetic, it can be attractive, it can be repulsive or attractive. Number 4. Number 2. They depend on distance. Okay, distance means, so the force, that is gravitational force, electrostatic force and magnetic force, in every case the distance plays a vital role. If you increase the distance, then the force will be less. If you decrease the distance, then the force will be more. Okay, so here the force is more if you decreasing the distance, the force is less if you increasing the distance. So for the case of non-contact forces, distance plays a vital role. If you increase it, the force will be decreased. If you decrease it, then the force will be increased. So that is the whole story of the examples of non-contact force. Okay.